Hello, this is a concentration problem. In this problem, we are asked to make a buffer of 200 milliliters with the following chemicals which are listed above: A, B, C and D. Two of them are available as dry powder and the other two are available as solutions. So your goal is to make this buffer, but the question is, how much would you weigh of A and B, and how much of C and D you would need to put it into water to make the buffer, and also how much water do you put in to get this 200 milliliters of buffer. Okay, let's crack on. A, let's start with the first one. So the chemical A, you need 10 milligrams per milliliters, the final concentration of that. That's what you need in the buffer. But I've got 200 milliliters of volume of the buffer. So in 200 milliliters, how many milligrams of A would I have? So I can cancel out the units, milliliters and milliliters. So it's going to be 2000 milligrams or 2 grams. So that's fine. So we've got A. That was quite straightforward. The B was we take 4 milligram per ml. That's what we need, the final concentration. But then we've got a volume of 200 milliliters. So we do the same thing. We can cancel out the milliliters. So we get 800 milligrams of B that is needed to be put into the buffer. So these are the dry powder that you can just weigh and put it into a beaker, mix it with a bit of water, and then wait for C and D. Number C. So we are given that we need a final concentration of 20%. That's the final concentration. But it is available as a 100% solution. So that's the available. But what is really needed is 20%. 100% is way too concentrated, so you need to bring it down to 20%. So what is the dilution factor? So it's going to be 100% divided by 20%. So it's going to be 5-fold diluted. You need to bring in a 5-fold dilution. And then we've got a volume of the buffer as 200 milliliters. So how much of the buffer C, the solution C you will take, which when diluted will yield 20%. So for that, so that's the final volume, and we need to take the concentrated solution and dilute it 5 times. So what's the volume we need? So if we can do that, to divide it by 5, so what that would yield is 40 milliliters of C. So if you take 40 milliliters of C and then you make it up to 200 milliliters eventually, so that's a 5-fold dilution, and that will bring the concentration of the concentrated C product from 100% to 20%, right? So that's the C. So we need 40 milliliters of C to be put into 200 milliliters of the final volume. 5 milligrams per milliliters of stock available. But then what we are needed is actually 10 micrograms per milliliters. So what we can do is, that's the final concentration. So in 200 milliliters of buffer, so we would have 10 micrograms per ml times 200, so that will be 2000 micrograms or 2 milligrams of compound D. So we need 2 milligrams of compound D, but we've got a stock of 5 milligrams per ml. That's the stock. So we can use C1 V1 equals C2 V2. So we've got the known concentration of the stock, 5 milligram per ml. We don't know the volume. And C2 V2, which is this one here that we have calculated, that's going to be 2 milligrams. So the V1, it's going to be 2 milligrams upon 5 milligrams times, it's actually the ml because it's the denominator, which when goes, it becomes ml in the numerator. So I can cancel out the units. So it's going to be 2 upon 5 milliliters or so it's going to be that many milliliters, 2.5 milliliters. So to make the final buffer, so you've got the A and B as dry powder. C would be 40 milliliters. The D is really low. It's less than a milliliters. So all you have to do is you've got to mix the dry powders A and B, take 40 milliliters of C, and then 2.5 milliliters of D, mix them up, and then make the volume to 200 milliliters in a measuring cylinder. So this way you've got a buffer which contains all the 5 ingredients.